Alright, so we're going to solve trigonometric equations again, but this time we're solving trig equations that are quadratic in nature. So we're going to start with A, solving that for 0 to 2 pi. We want the exact values. Now notice that quadratic is equal to 0, so when quadratics are equal to 0, we factor. So both terms have sine of x times 2 sine x plus 1 equals 0. Okay, now that it's factored, we set each factor equal to 0. So sine x equals 0, or 2 sine x plus 1 equals 0. I'll start with this small one first. Sine x equals 0. Well, where does sine of x equal 0? Think about the unit circle. It equals 0 at 2 pi. And it equals 0 at 0. And it equals 0 at pi. At those three values. And it's only those three values. We don't need to worry about adding on 2 pi k to this, because those are the only three values between 0 and 2 pi where the sine of x is equal to 0. Now we look at the second one. And we need to get sine of x alone. Divide by 2. Sine x equals negative 1/2. So where does sine x equal negative 1/2? Sine x equals negative 1/2 when x is 7 pi over 6, or when x is 11 pi over 6. And with this problem, there are 5 solutions. There's 3 right there, and 2 more right there. Let's take a look at the next one. So here, the factoring is a little bit more than just factor out a common term. We're going to need 2 sets of parentheses. We'll have 2 cosine x in one, cosine x in the other, and we need to have these multiply to negative 1 and add to positive 1. And there's our factorization. So 2 cosine x minus 1 equals 0, or cosine x plus 1 equals 0. I'll start with the small one. Cosine x equals negative 1. Get the cosine x alone. So where does the cosine equal negative 1? Well, between 0 and 2 pi, the only place where cosine of x equals negative 1 is when x equals pi radians. We now have our second mini equation to solve. We add 1. Divide by 2. Cosine x equals 1/2. Within 0 to 2 pi, where does that happen? Well, it happens when x is pi over 3, or when x equals 5 pi over 3. Quadrant 1 and quadrant 4, we have 3 solutions to this quadratic trigonometric equation. All we're doing here is we're combining our skills with quadratics and our skills with solving trig equations. There's nothing drastically new, just combining 2 old things in a new way.